Welcome to Deeper Perspectives, the greatest spearfishing podcast. Alright, here's access to the secret laboratory. I want to talk to you about some real numbers with weight. So what I'm doing there is exhaling. With full lungs, I float, but as I exhale at some point, I start to sink. So I'm going to measure what that volume is. A liter of air displaces a liter of water, which weighs 1 kilogram or 2.2 pounds. So for each liter of air in your lungs, it's 2.2 pounds of buoyancy on the surface, you could say. And so I found that I start sinking and then I'm able to still exhale 1 liter. So there's still a liter in my lungs as I start to sink. But actually there's 2 liters in my lungs because of something called residual volume. Even after you exhale all your air, you still have some air left, right? Your lungs haven't collapsed. So let's just say I'm an average person. That's about an additional liter for residual volume. So anyway, with 2 liters in my lungs, I'm a sinker. I'm negative buoyant. So let's just assume I have average lungs for a man. That would be 6 liters on the surface. Half that at 33 feet, which is 3 liters, and at 66 feet, I would have 2 liters, which again, remember, that's where I start to sink. So at 66 feet, on a full breath, I would be negatively buoyant with no weight. But of course, most of us also wear a wetsuit, which is also a major source of buoyancy. So here I'll show you how much buoyancy you're getting from a 2 mil, 2-piece, extra large but skinny wetsuit. In fact, spoiler alert, I'll just tell you that on the surface it takes about 10 pounds to sink this 2 mil wetsuit. So we'll say 9 pounds of buoyancy since 10 pounds sinks it. Once you take it to depth, different neoprenes have different characteristics of compressibility. But if you're using Yamamoto 39, that is by Yamamoto's own terms a surface-rated neoprene. So if that's what you got, you can pretty much assume that you're down to half the thickness and the buoyancy by 33 feet. So from 9 pounds, let's say now you've got 4.5 pounds of buoyancy. At 66 feet, 3 pounds of buoyancy. At 100 feet, a little over 2 pounds of buoyancy on the 2 mil wetsuit. But let's go back to part 1 and put it all together. We'll use 66 feet as an example. So if you remember, that's when our lungs had compressed from 6 liters on the surface all the way down to 2 liters, and that's when I'm starting to sink. And so we'll say I'm like a 1 pound negatively buoyant there. But the wetsuit, as we just said, has 3 pounds of positive buoyancy. So you would need a weight belt of about 2 pounds, the difference between my negative buoyancy and the positive buoyancy of the wetsuit, to keep you neutral. Or to keep you stuck to the bottom, you could wear 3 pounds, which is probably, with a 2 mil wetsuit, about what I would use to dive 66 feet.